Let's go to page 139, and this is section 11.7. And this is introduction to trigonometry. So whenever you have right triangle, there's different ratios. There are 6 possible ratios. So if I triangle A, B, C with a right angle at C, so this would be small a, small b, small c. So you're going to have 6 different ratios of combinations. Okay, so you're going to have the A over C, then you have the B over C, you have A over B, and then you have C over B, and you have C over A, and you have the B over A. Okay, so you have 6 different combinations. Now each of these combination will have a name for it. Okay, so the first one is sine. Okay. The name always take the first 3 letters. So sine will give you sin. So sine of in this case, I'm going to put an A over here. I'm going to put B over here. So sine of angle A would be the opposite of a hypotenuse, so it would be A over C. Okay, and cosine is a complementary angle of sine, or complement of sine. Okay, so cosine would be B over C. Okay, and also this would be the opposite of a hypotenuse, and cosine would be adjacent of a hypotenuse. So I'd like to kind of do a sine, cosine, and tangent. Tangent is a slope. So sine how to deal with the vertical, cosine is the horizontal, and tangent is the slope. So it'd be opposite over adjacent. So it'd be A over B, which is the opposite over adjacent. Okay. Now the other 3, so these are primary function. The other 3 functions, secondary function, would be just a reciprocal of that. Okay, so the reciprocal of sine is cosecant. So cosecant of A would be C over A. So this would be hypotenuse over opposite. Okay. And notice each pair, one of them will have the complementary angle or complement. Okay, so this one does not have a co, so this will have a co. This one have a co, so this will not have co. So this will be just secant of A, would be just C over B, or hypotenuse over adjacent. And same thing over here. So tangent, the one go with tangent would be cotangent. The cotangent A would be B over A, and this would equal to adjacent over opposite. So these are the relationship between the 2 of the sides. And because because the cosine is a complement of a sine, so sine A is equal to cosine B, or equal to cosine of 90 degrees minus A. Okay, so these are the relationship between sine and cosine. And if you use a Pythagorean identity, you're going to get sine squared A plus cosine squared A equal to 1. Okay. So these are the Pythagorean identity, very important identity you need to know. And from here, from this, if you divide every term by cosine, then you're going to divide everything by cosine, then you're going to get tangent squared A plus 1. So 1 over cosine would be secant, so it would be secant squared A. Okay, if you divide it by cosine. If you divide it by sine, you're going to get 1 plus cotangent squared A, and you're going to get cosecant squared A. Okay. So this is some idea. Now, for trigonometry, the actual number does not matter because this is based on the ratio, and so there are several special triangles that you need to know. So if you have, if you start with the 45-45 special triangle, so the basic one would be 1 square root of 2, and any multiple of that. So if this is 10, this would be 10, and this would be 10 square root of 2. Okay, and then the 30-60 So this is the 30, 60 spatial triangle. And the relationship of that would be 1, 2, square root of 3. Okay? So again, the hypotenuse will be twice as that. And it's kind of notice there's a pattern to it. So if you kind of rearrange this, right? Notice that this is square root of 1, square root of 2, square root of 3, square root of 4, right? So again, square root of 1, square root of 2, square root of 3, square root of 4. And this came from cutting a square into half, okay? So 1, 1, 1, 1, right? And you cut this in half and use Pythagorean Theorem, you get square root of 2, right? A squared plus B squared equal to C squared. This came from cutting an equilateral triangle, okay? So this would be 2, 2, 2, right? Equilateral triangle, you cut in half, so this would be 1. And use your Pythagorean Theorem, A squared plus B squared equal to C squared, this will give you square root of 3, okay? So again, if you don't remember, you just have to start out with your square and equilateral triangle and cut in half and to get that. Okay, so from here you can go ahead and able to evaluate spatial angles. Okay. There are also some spatial angles, like for example, if you have a triangle that's, let's say, like 15 degrees, okay? With a 15 degrees, the long leg would be square root of 6 minus square root of 2 over 4. The short leg would be minus, the long leg would be plus. Okay? And again, this would be 1, right? So, okay. And you can kind of check, okay, so again, these are spatial triangles, okay. Now, there are other ones, like 18 degrees and 72 degrees, or they are like 36 and 54. So there are some that are able to also give you kind of numbers, okay. But we're not going to cover that. So this one comes more often, so you can kind of use that. Now, if you have, like, let's say if you're in a different quadrant, let's say if you're like over here, okay, let's say this is 75 degrees, okay. So in this case, again, this is the short leg, right? So the way to use this is the short leg, so it'd be the subtraction, okay, and this is the long leg, okay. Now this is positive, so this is good, but this is negative, so you have to times this by -1, okay. So if it's a negative, you have to put a negative in front of that. So this would become square root of 2 minus square root of 6 over 4, okay, instead. But you start out with that the length, and then you worry about the positive negative afterward. Okay, so let's go to example 11-6. 11-16. So it's giving that angle B is 90 degrees. Okay, and cotangent of C okay, so this C, this is A. So cotangent of C, cotangent is cosine over sine, so 5 over 6, so it would be 5 over 6. But remember, these are not actual numbers, so this is like, these are just the ratio, so you don't know what original number is. So you can put it like a multiplier, okay? So just be aware of that. It says one side BC, okay, if AC equal to 5 square root of 61, okay? Okay, so from here you can go and figure out what the n is, okay? So again, the ratio is the cotangent is cosine over sine, and it's 5 over 6. But again, these are not the actual number, there's a multiplier. So if you apply the Pythagorean theorem, so you got the a squared plus b squared equal to c squared, right? So you're going to get 25n squared plus 36n squared equal to 25 times 61. Okay, and you add this together, you're going to get 61n squared equal to 25 times 61. Now you can see why I don't multiply all the numbers, because you can see you can just cancel out. So n equal to 5, Now you don't have to worry about negative because this is a physical object, right? So in this case, n equal to 5. So BC will equal to 25. Okay. Okay, let's go to example 11-17. Okay, so you have, again, when you have the right triangle, draw a 30-60. That way when you draw, you can able to tell which is long, which is short. Okay, so from the side of the BC, so you're looking for this up here, BC, of the triangle ABC, if AB equal to 8, and AC equal to 8 square root of 2, and angle ABC equal to 45 degrees, so this would be 45 degrees, and angle ACB equal to 30, so ACB equal to 30 degrees, okay? Now this one, do not assume that this is a 90 degree over here, okay? But this is 30, so this would be 60, right? Okay, so this is not too bad. So from here, so BD will equal to, from hypotenuse to the leg, you have to divide by square root of 2, okay? And DC equal to, okay? So from here, you have to, so the short leg is half of that, so this will be 4 square root of 2. And you times by square root of 3, so DC will equal to 4 square root of 6. So BC will equal to, I'm going to simplify this. So BD is equal to 4 square root of 2. So BC will equal to 4 square root of 2 plus 4 square root of 6. Okay, and that's it.